Hello everyone, welcome to the study of ODE, whereby we are going to solve this second order difference equation given that second derivative of y with respect to x plus 5 first derivative of y with respect to x plus y is equal to 0. So we expect our solution to be of the form our solution is expected to be of the form y is equal to c1 exponential m1x plus c2 exponential m2x. So we are going to let our y to be equal to exponential mx. Then we differentiate y prime is equal to m exponential mx. Then we differentiate y second time. So you don't get m squared exponential mx. Note that here y prime is the same as dy over dx, which you have found it is m exponential mx, and y double prime is the same as second derivative of y with respect to x, which you have found to be m squared exponential mx. Then once we obtain our result, we are going to substitute them in this equation, the value of y prime and the value of y double prime. So we are going to get m squared. Substituting, we shall get m squared exponential mx plus 5m exponential mx plus 6 exponential mx, which is equal to 0. Substituting the derivative of first derivative of y and the second derivative of y. Then we can factor exponential mx to be left with m squared plus 5m plus 6, which is equal to 0. Now in this case, in order for our equation to hold, it implies that it means this, that exponential mx cannot be equal to 0, never. Meaning that now, what is equal to 0, it is this quadrant, what is in the bracket, m squared plus 5m plus 6, which is equal to 0. Now, this is a quadratic equation whereby we have the product is 6, the sum is 5. So you ask yourself, what are the two numbers which when you multiply you get 6, and when you add you get 5. So you have 6, you can have something like this here, 6. Those two numbers, it is 2 and 3. Because 2 plus 3 is 5, and 2 times 3 is 6. So you use them to solve your quadratic. So you have m squared plus 2m plus 5m plus 6 is equal to 0. From that one, you can factor here, you can factor m. You'll be left with the m plus 2. From the last, this should be 3, sorry, this is 3. From the last pair, you factor, because we are substituting the value of m with 2 and 3, which is 2 plus 3 is 5m. So you factor 3 plus 3 into bracket. So here you will be left with the m plus 2. This is equal to 0. So you will have m plus 3 bracket m plus 2. This is equal to 0. Meaning that either m plus 3 is equal to 0, meaning that m is equal to negative 3, or m plus 2 is equal to 0, meaning that your m is equal to negative 2. Your m is equal to negative 2. So our m1 is equal to negative 2. Our m2 is equal to negative 3. Then we come back to our general equation, which was y is equal to c1 exponential m1x plus c2 exponential m2x, which is equal to, we can substitute now our value as c1 exponential negative 2x plus c2 exponential negative 3x. So this is the general solution of our given ODE. Now you can always check you are working whether it is correct. You can check whereby we get y prime, which will give us negative 2c 1 exponential negative 2x minus this other one. It will give you 3c2 exponential negative 3x. Then we get y double prime, which will be equal to, I can write y double prime here, down here. Y double prime is equal to, this one will give you 4c1 exponential negative 2x plus 9c2 exponential negative 3x. On how to differentiate exponentials, check in my YouTube channel. I've already done it for us. Then given ODE is this y double prime plus 5y single prime plus 6y is equal to 0. So you want to substitute them here and see what we are going to obtain. So you will have 4, instead of this double prime you write 4 c1 exponential negative 2x plus 9c2 exponential negative 3x. Then you have 5, so you multiply negative 2 times 5. We are substituting here. So y single prime, it is negative 2. So negative 2 times 5 will give you negative 10 c1 exponential negative 2x. Then you have negative 3 times 5 will give you negative 15 c negative 15 c2 exponential negative 3x. Then plus you have 6 times our solution, which is here. So you have 6 c1 exponential negative 2x plus 6c2 exponential negative 3x. So here we have 4c1 minus 10c1, that will give you negative 6 plus 6, which will give you 0. Then we have 9c2 minus 15 c2, that will give you negative 6 plus 6, which will give you plus 0, which is equal to 0. So meaning that our working is correct. So thanks so much for taking time to study with me this example on linear differential equation of the second order. So our solution, our general solution is this one. For further examples of the same nature, tune in my YouTube channel so that we may continue learning together. Bye bye. See you in the next presentation.